Okay, good morning again, everybody. Thank you for joining us today. I think we're just about ready to get started here, and we just left it for a couple of minutes for give people an opportunity to join us. But I think we're ready to go. Ahmad, you got your coffee?
Yeah,
You've got your hand sanitizer. Good. It's ready to go. So, yeah, we'll start here today with just a quick introduction. So my name is Karl Metcalf. I'm Vice President of Business Development here with Integrity Plugz. Been with Integrity Plugz here for almost 4 years now, so it's been 4 years of lots of fun, so it's been good. I have a degree in Business and Procurement Supply Management, and I've over 18 years experience in the construction and the oil and gas industry. Joining me today for today's webinar is my colleague Ahmad. Ahmad, would you like to do a quick introduction?
Thanks, Karl. Hi, everyone. This is Ahmad Rana. I'm the Technology Commercialization Director with the team Integrity. I have master's degree in Materials and Corrosion Engineering, and I have slightly more than 10 years of experience performing the field inspection, asset integrity, as well as R&D functions for corrosion.
Fantastic. So just a quick run through on today's agenda. So we're going to be discussing CUI and the damage some other damage mechanisms. We're going to be looking at condition monitoring locations overview. We're going to look at our inspection port selection criteria, so some of the items that you might consider when you're trying to select a particular type of inspection port. We'll then specifically look at our Integrity Plugz. We'll have a quick run through the rest of our product range. We'll do a summary, and then we'll leave some time at the end then for participants' questions. So yeah, so to get us started then, Ahmad, we might just get right into it. We'll start talking about some of the degradation mechanisms, specifically kind of in relation to inspection ports.
Yeah, thanks, Karl. Yeah. So this is the I would say short summary of some damage mechanisms that have been reported by American Petroleum Institute. I think these may be 20 or 30 damage mechanisms, but they are total 17 numbers, and they have the different triggers for the happening of each damage mechanism and different failure modes and how they look like. But there is a commonality with all damage mechanisms that they can be inspected and accordingly they can be mitigated. In this figure, like in this slide, we can see the damage mechanism that are red highlighted and underlined. So these are all the damage mechanisms that can be inspected or that can be diagnosed through the use of the inspection ports or condition monitoring locations. So like speaking about the cavitation, erosion, corrosion, these are the like quite common damage mechanisms in the piping system, and also like the galvanic corrosion, caustic corrosion, and especially when it comes to the refinery, there are like state-of-art damage mechanism like naphthenic acid corrosion or ammonium chloride. So they all require some sort of non-destructive examination on the external surface of the pipe, and that's why we need any inspection port or condition monitoring locations. Like the damage mechanism thermal fatigues or dissimilar metal weld cracking, we don't require any external, like the UT measurements and stuff like that. So we need to have an optimized inspection plan. And for these damage mechanisms, the inspection plan or the inspection strategy should take into consideration the CMLs or inspection ports. So in this slide, the one damage mechanism I have shown like with a cross in front of that is a CUI. It's a corrosion under insulation. The reason why I have made it crossed and unique, because it's a damage mechanism and highly unpredictable. And this damage mechanism that doesn't regard for the integrity operating windows. So I would just like throw some light quickly on the concept of integrity operating windows, like within the asset integrity program. So it seems like we have an old-fashioned car, so we will try to like run it at lower speed, and we won't try to use it for making the long for traveling to the remote locations. So same way, depending on the damage mechanism in the process equipments, we try to so I would say lower down the operating conditions, so to avoid any sort of like failure in the equipment. So that is the concept of IOW. But the CUI, even it's happening, we cannot actually predict how much we have to reduce or underrate the vessel or the asset. So that's why it doesn't record for any IOWs. And the other problem with the CUI is that it's a very frequent damage mechanism in the piping system. It's a reported fact that 40 to 60% failure in the process piping is because of CUI. And if we try to narrow down and try to focus on the small bore piping or less than 4 inch and less than 4 inch, 81% of the failure in those piping means because of CUI. That means these piping are more sensitive towards CUI. And Exxon study published in 2003 that has revealed that 10% of the maintenance budget is spent on dealing with the CUI-related problems. And if we try to quantify with even using the modern recommended practices, the prediction of the CUI rate is itself like a gray area. So that takes into consideration like very, I would say, extensive factors like the piping and equipment interface factors and multiple design factor, type of insulation, condition of insulation, and the proximity and the neighborhood condition. They take into consideration all the different factors for CUI measurement. And the reason why we are talking about the CUI in the context of this presentation, because there are many instances from the location of the damaged inspection port or the location of the bad CMLs. So there is a likely moisture intrusion. And we will talk about that in upcoming slides, how the API standards, they talk about that. So talking about the CML, condition monitoring locations, what is that? So basically we need to understand this. API 570, that is a construction code for the process piping, that I would say inspection code for the process piping. So this says CML as a set of examination points. And this only regards examination point as the examination of thickness loss. So I would say thickness measurement locations or the TMLs. But if we dig into API 574, that talks further about the inspection practices related to the piping systems. So that regards CML as a location for damage mechanism investigation rather than only a thickness monitoring location. So this is the key difference between how these two standards interpret the CMLs. And when we talk about the insulated system, so insulated system CML has to be protected by the use of some sort of inspection port. So when we talk about the criteria or I would say some rules for the selection of the CML points or the selection of the inspection ports within the loop or the piping, assemblies of the complex piping bundles, we need to install something, like called CML or the inspection ports. So we can take a lot of factors, and these factors have already been addressed, or could be some factors could be unaddressed in the specifications, asset owner specifications, and the recommendations by the licensors. So these are generally, in general, these are addressed over there. And it's very important to address that during the design phase, as the asset integrity field is evolving, Karl, so the designers are mostly, addressing this from the very first time, like that.
Yeah, absolutely. And we get asked this question a lot, that, can we help specify the location of where inspection ports should be installed? But I mean, there's so many different aspects that it's really hard to do that. I mean, we can of course say, at any change in direction or any junction, anywhere where you've seen historical problems of corrosion. But I mean, it's very specific to the asset owner and the history of their plant and what they've seen, because again, for the most part, they want to have a certain number as well that are kind of randomly installed, just so you're getting a good random sample of the condition of the pipe at that specific location.
Exactly, and also it's also dependent on the corrosion, what type of corrosion. It's a general corrosion or localized corrosion. So these two factors can definitely impact the location as well as the number of inspection ports, and also definitely the budget kept for the asset integrity program. So as I mentioned that previously, the API 574 is talking about the investigation of the damage mechanism. 570 is talking about the investigation of thickness loss. But there is another interesting thing about the inspection ports of the CML is that it's a telltale thing for the process, optimization as well. For example, we are using some inhibitors, some, like neutralizing chemicals, and that are quite frequently used in the oil refineries and petrochemicals, where they might be injecting hydrazine or other chemicals to reduce the aggressive nature of the service. So because that can impact the corrosion rate. So we need to we need to have some sort of condition monitoring location, even to quantify or to qualify the effectiveness of the injection programs, the chemical injection programs. So like this is complete, like this is the picture showing like the recommended locations where we need to conduct the radiography or the ultrasonic thickness, considering the location of the chemical injection. And also, like, some interesting thing is like with inhibitors is that like there have been in market like inhibitors called filming inhibitors. So filming inhibitors, what they do, they build a protective or passive layer on the inner surface of the pipe. So whenever they are injecting the inhibitors, so accordingly the corrosion rate on the pipe could be minimized, and accordingly that reduced corrosion rate has to be monitored from the external surface of the pipe via CMLs. So that's why it's very important for the process optimization.
Yeah, and here, Ahmad, as well, just some of the other aspects that some of the other questions that you may be asking in trying to select the proper inspection port for your application are obviously like the access size requirements. So maybe depending on the type of test that they're doing, the size of their equipment, how thick the insulation is, access size is one of the big considerations.
Yeah, absolutely. Yeah, like if we talk about the access size, so I would say it's very much decisive on the inspection program. We might come across a situation where we have an inspection board, where we have a CML properly defined, but the size is too small that it cannot give you a quality data. So I can give you an example, like API 579 is a standard that is meant for the FFS, fitness for service assessment of the pressure vessels and the piping systems. So what is the challenge being addressed for the CML point of view is a factor called coefficient of variance. So for example, if we are taking the ultrasonic thickness at a pipe and it's too small, we can get only one reading. So one reading could be underrated or exaggerated. It could be anything.
For sure, and you want to use that inspection point as to be able to represent the rest of the line. So if you're just testing at one specific point, it's hard to say that data is representative of the rest of the line.
Exactly.
So that's kind of why we see that there's certainly been a change in recent years towards having much larger inspection ports where you can test over a larger area, get better, more accurate data.
Absolutely, absolutely. And that's why they recommend that to keep it less than 10%, has as many data points to keep the coefficient of variance. And also, yeah.
Sorry, Ahmad.
It's okay.
A little bit.
Oh, no problem.
But yeah, just to kind of continue to talk through some of these questions that you might be asking yourself. Obviously, the location of where you want to install it. Again, we've seen it to be a big question that we get asked often, because again, depending on how tight the piping systems are, the owner always wants to gain the maximum access. But if you're in a very tight piping situation, you need to be able to balance the right size with the application.
Absolutely.
Of course, the pipe size, the process temperature, the insulation and cladding type that you're using, how thick it is, if it's traditional cladding, if it's non-metallic cladding, it's definitely a consideration. Availability of the product, so depending on where you are in the world, is the product available? Us ourselves, we do have a kind of a global distribution network at the moment, so we can certainly provide ports anywhere in the world. The obviously cost, especially these days, is a bigger and bigger factor kind of thing. But again, so it's kind of, we see some people will concentrate on the unit cost of the product, but really you have to consider the labor cost for the install and the total cost of ownership. Like, is that port doing the job you want it to do? Is it going to stay sealed? Like in the picture that we had here, Ahmad, if you have an inspection port which is allowing water ingress due to poor performance, lack of sealing, actual water ingress points built into this kind of old style of port, which we display here, you're really defeating the purpose. You're going to find corrosion right where you're looking for it because you're using a per performing inspection port.
Yeah, absolutely. And also, like, imagine that it's a medium pressure steam line. Let's say the temperature of the steam is 200 degrees Celsius. How much heat loss we would be expecting in the cold weather of Canada, like that?
For sure, yeah.
Yeah.
Yeah. And again, it's not representative of the rest of the line. Like if the port itself is allowing water ingress, then obviously you're going to see bad condition there, but it's not representative of the rest of the line. So again, like as I said, performance and then just ease of use, critically important to the not only the installer but the user, the NDT company who's going to have to use them on a repeat basis. So yeah, so API 581, that is, I would say, the core document for the detailed risk-based inspection, the procedures. So like in this figure, we can see that inspection port, although it looks nice and shiny, but we can clearly see some gap on the sideways. So like in the climate where there is a snow pileup on the surface, and especially in the event when the temperature is increasing, so the snow will melt and the moisture will find its way easy peasy into the system. And this is definitely more of a problem in Canada where we are, where you get lots of snow. But again, like even with this picture, Ahmad, like you see that the metal piece has been cut and crimped. It's probably been silicone behind it and then screwed into place. But what does that look like when the inspector comes along, he removes it, and then he has to try and install it and form a watertight seal again? So usually we see this kind of traditional type of crimped metal piece get beat up pretty quickly and allow water ingress almost immediately, like after the first kind of test. So this is actually a good photo. This is probably one of the better ones you're going to see of this kind of metal crimped piece. But again, it's not fulfilling the purpose of the inspection port.
Absolutely. And that's why API 581 has emphasized that inspection port system, although it's good for the data acquisition, but we need to promptly replace and reseal of the plugs. And normally, as Karl, you mentioned that they can reseal that with the silicone, but silicone is not like a long-term solution. It can easily, the degradation can happen easily over the time.
Yes, the silicone is definitely going to be one of those maintenance pieces that needs to be re-siliconed every 1 or 2 years.
Absolutely.
So, and again, like you'd have to ask yourself, is the inspector going to re-silicone when he does the test?
Absolutely.
So I mean, it's critical that those items are done.
And also API 583, that is a dedicated standard for CUI and CUF corrosion under fireproofing. So that document is having a risk matrix for the condition monitoring location ports of the inspection plugs. And apparently that standard is saying that, okay, if some system is having inspection ports, the risk factor could be 0 to 1. So when they say inspection port means it's a good inspection port, we have to understand that. But if the inspection port is allowing the moisture, so the risk could be higher. So the score for the good inspection port, that is 0 to 1, it can turn into 5 if the port is bad. So definitely, so it can degradation can happen very quickly over the time. And another thing is about the durability of the material. So we can see this instance like the inspection port. I believe it's a sealing of the edges as well, and also maybe, Karl, for the visibility purpose, they want to show it to someone like this.
But perhaps if it was me, I'd be trying to hide it. But yeah, certainly here again, this is kind of, and again, we still see lots of this in the field where people are trying to just make their own inspection ports in the field, and this is kind of what it leads to, is kind of like duct tape and stuff being used to try and seal it. So again, it kind of flows into what we were discussing in the total cost of ownership and ease of use. I mean, obviously you can imagine an inspector coming along to this piece and trying to peel off the tape and gain access and then retape it afterwards. It's going to take more time to do this inspection. Yeah, still I'm like feeling challenged whether it's a tape or it's an adhesive one, that I can't figure out. But like the main challenge with that, like the durability,
especially in the event when the system is mechanically abused, like someone stepping on the lines, and also like in the climates like the Gulf Coast, we have the issue of the ultraviolet radiations. So in that case, the port can be easily compromised or the damage over the time. So like even if some like the trademark ports are being used, they can those can be compromised. So even the 583 standard that clearly says about the durability, that like the areas where the insulation plug is there, they can be easily they could be high risk when the port is damaged or misplaced.
Sure.
And another thing that is about the losses from the system, as I mentioned earlier, the inspection port that is improperly installed, and the port that is especially that is missing the insulation from the system, the cutout insulation, that can be subjected to thermal losses. So it's quite common practice across the industries, like where they need to make the entity examination. They just make a window by cutting out the insulation. They take it out and they might place it on the platform or something. Or it might be a rainy day or the foggy day or something. The insulation is trapping the moisture.
And I've even seen firsthand like insulation being reinstated back into the cavity, and it's half insulation, half snow. But it's very hard to replace that cutaway insulation to the same sort of integrity as you'd want in the system.
Exactly.
And it was an item just like this was the driver behind our development of our integrity pillows, which kind of solved this problem. But again, we can talk about them in later slides. But yeah, this is still something that you see regularly in the field.
Yeah, here is something like if we just try to take this system and compare it as per API 583. So the very simple question that we can pose on ourselves, whether the risk rating for this system before making the window is same as it is after making the window. So that could be the question we can pose ourselves. And also the other problem could be that is the risk rating for CUI. The other problem could be the thermal losses. Definitely, if there's a system was running at high temperature, we need more thermal energy and more fuel to maintain the same temperature of the system, and thermal loss is definitely a problem in that case. So Karl, as you mentioned earlier, ease of use, especially with our colleagues and the fellows who are in the industry doing the raw access thing. So they have everyone having two hands, two pockets.
Yeah, I think this is the big thing, like with our integrity plugs, that they are attached with a lanyard. So once you open them, that they will hang there. And also, if you're going to use our integrity pillow, which again attaches via a lanyard to the inside of the inspection port, it allows the inspector, especially like in a rope access environment, freedom to be still able to use his two hands. You open the port, you take out the pillow, they can both hang there freely, do your work, and then easy to kind of reinstall them. Again, where we were talking about on the last slide with the insulation not being replaced properly, we've seen kind of or we've had rope access people tell us that, they take out that insulation, they're trying to put it in their pockets or secure it somewhere so they can put it back in. So it just makes the job a little bit more difficult. But certainly, having a size to match each application and temperature range. Again, our inspection ports come with a complete package, so you're getting a template for the cutout hole, you're getting all the hardware that you need. They're easy to install. We have a QR code on there, so you can scan the QR code. It brings you straight to an installed video. And again, that's service life that we have because we use very high grade quality materials. And we have a service life of 25 years service life. And we've even seen our inspection ports being removed and reused somewhere else. That's how adaptable they are.
Absolutely. Yeah, and like previously, as I mentioned about the missing insulation, like this sort of thing can easily be overlooked during even the inspection walkthroughs, especially when they're at those elevated platforms.
Especially if it's covered up, like if the metal piece here has been put back in place, you don't know the insulation is missing behind it.
Exactly, yeah. And also like when they are making the punch items list, if it's on the elevated platforms, it can remain undetected.
Yeah, for sure. So let's get into talk about our integrity plugs in a little bit more detail. So right from the start, we kind of built the port from a very kind of engineered level. The flexible metal skeleton is one of the key elements of the inspection port. So our port is the only port available on the market that can actually bend and contour to suit the curvature of the cladding which it's been installed into. So in turn, this leaves it that it's much easier to form that watertight seal and to be able to maintain it. So that, together with the precision fit between the edge trim and the cover piece, guarantee that you can form a watertight seal. Within the operating temperatures as well of -150 to +450 Fahrenheit, the inspection port will remain as pliable and workable as it would at a normal kind of temperature. The simplicity is something that we like to highlight. They, very easy to install. They install quite quickly, under 3 minutes for sure. Allow you to do quick and easy testing. And as we mentioned, each package comes with a full set of instruction, template, the screws and hardware that you need, and no special tools required for the install. In terms of flexibility, we've seen them used in any number of places, but yeah, they can certainly be used on elbows, small bore piping, corrugated sheeting, tanks vessels. They work with all types of insulation, particularly kind of low profile installations. They work particularly well with. Again, Integrity being a huge part of the product itself and carries the company name, maintaining that watertight seal has been one of the key aspects of why our inspection ports have become so popular. And again, Ahmad, I think we had a number of asset owners who we approached who just seen inspection ports as a future maintenance problem, that it was something that it was going to allow water ingress. It had to be maintained. You had to upkeep the silicone. They were difficult to open and close. And they'd go away from the idea of using an inspection port and prefer to remove cladding, remove insulation. But we've been very successful in, displaying our port to them and that it's going to maintain that watertight seal and very easy to use. So we've been very successful in changing the mindset of a lot of asset owners to adapt our inspection ports.
Yeah, I remember some successful field trials we did that, and eventually they ended up liking getting our product spec.
Yeah, absolutely. Yeah. To speak of access, then we've got the largest range of sizes available on the market. So we have right from our small 2.5-inch round inspection port up to our 14 by 4.5-inch oval, which is great for the large bore piping, tanks, vessels, that kind of work. And as I say here, kind of all allow kind of repeat access for ongoing asset integrity management. Visibility, they're a very functional design, highly visible, aesthetically pleasing. We've got some field shots which we'll go through here in a moment, but generally we find that the contractors like using them. They install very nicely. You get a nice clean finish with the install. Safety obviously is something that's very big in our organization and also throughout the industry. So again, one of the key aspects of our inspection port is that there's no sharp edge on the inside. It's completely encased in silicone. So you've got a nice smooth silicone inner edge trim. So it allows you to safely be able to do your inspection. And of course, all this adds to your profitability, saving you time and money. So here's just a couple of quick shots. You can see on the left-hand side here, the inspection ports can be bent into some quite extreme scenarios and still remain workable, even bent to this sort of degree. And it's because of the flexible metal skeleton that's embedded in the edge trim. And this silicone then is actually bonded directly to the metal. We use an 18 gauge steel for the metal, and in our manufacturing process, the silicone is actually poured at a very specific rate at a specific temperature, and then allowed to cool along the right time frame so that the silicone actually bonds to the metal. So this helps kind of spread the load of the bend and the curvature. You're not going to get any kinking of the metal or metal fatigue at one particular spot. So these are just some of the product sizes that we have available. So as I mentioned, from our 2.5-inch round right up to our 14 by 4.5-inch oval. So with this kind of number of sizes available, you really can find an inspection port to suit your specific application. As mentioned, each inspection port comes with a full kit. So we have the inspection port itself. There's a cardboard template which you can use just to put onto the pipe and mark out your cut hole. You come with a full list of instructions, and as I mentioned, you have that QR code which you can scan with your phone, brings you directly to an install video. And just this month, our Integrity Plugz now come with the Gerbil Duplex 318 LN stainless steel screw. So very, very high quality stainless steel screw. Again, another item just worth mentioning is the unique low profile design which our port has. So you can see on the top picture here, the Integrity Plug is on the right hand side, and it's just in comparison to a more traditional type of inspection port on the left hand side there. But that low profile design is key in many scenarios, especially if you're using low profile insulation systems like aerogels or something like this. They can be 5 or 10 millimeters. So our port has a total thickness of 20 millimeters, but it only penetrates in through the cladding and into the insulation 4 millimeters. So the vast majority of the plug actually sits on the outside of the cladding.
Yeah, I think that is very interesting to know because there is a lot of innovation coming with the insulation systems, like the size of insulation, thickness of insulation is reducing day by day with the use of the advanced materials. Now they are with more.
Absolutely, there's just many manufacturers now have a low profile hydrophobic insulation alternative, and which works great, especially in kind of cramped piping conditions. Like if you can install 20 millimeters of insulation rather than 3 inches, so like this, there's huge advantages to it. So again, we see that our plug works particularly well in this scenario. We've seen some other plugs that are available on the market. They have different ports that work in only one application, where we kind of built our inspection port to work in many applications. This is just some nice field shots of, I think that's our 9.5 by 3.5-inch inspection port installed on a tight 90-degree elbow. So you can see it kind of takes that form and curve quite well. And using conjunction then with our Integrity pillows, as you can see here, you're able to open the Integrity plug and it will hang there via the lanyard, and then you can remove the pillow, which replaces that cutaway insulation which we spoke of, and they will both hang there. Do your test, easy to reinstall them and close them. Because everything in the oil and gas industry needs to be able to take a punch, I thought we'd have a look at some photos of plugs that have been out in the field for a number of years. We usually have nice, clean, crisp marketing photos of our inspection ports, but it's nice to see and we see it often when we go to do asset owner visits and Karl and Ahmad, and you see them there being installed for maybe 4 or 5 years. Yeah. They've been taken and beaten. It's no problem to them. One of the key aspects of our inspection port, like the center photo here, is that flexible metal skeleton allows the port to be able to bend and manipulate to any sort of mechanical damage that it might receive, while still maintaining the watertight seal. You can still go and use this inspection port if you wish. You might have other problems with the cladding, but the port itself is maintaining that watertight seal.
Yeah, just imagine like in the event of snow, thunderstorms, or rains, if the port is being damaged, it could be. Yeah, it has to be replaced.
I think certainly a lot of care needs to be put into the inspection port selection, because many asset owners have told us that it's one of the high-risk water ingress points if it's not correct. And we've also seen, again, some kind of traditional ports that are available in the market that they just don't have a great temperature range. So whether it gets too cold, the cover will shrink. Yeah, it will experience shrinkage and literally fall out, and then you've got an open hole in your insulation system. And I always kind of think of it that asset owners spend millions of dollars on their their insulation and cladding systems, and you know, it's not good enough to put a cheap port in there that's not going to do its job and will potentially lead to lots of problems.
Absolutely.
We also do our inspection ports in an EPDM variant. So these come in all the same sizes, same package, everything like this. The only difference being that our silicone port has a temperature range of -150 to +450 Fahrenheit. Our EPDM variant is -58 to +300 degrees Fahrenheit. So if you've got a lower process temperature, the EPDM is certainly a good alternative as well. As I mentioned, our Integrity Plugz are an item that work in conjunction with our inspection port. They replace the cutaway insulation and act as almost like a heat barrier to the inspection port if you've got a very high process temperature. We make them with a vermiculite fabric and a 1-inch e-glass core, but we can make them from different fabrics and different cores if requested. Again, they attach to the inside of the inspection port via a lanyard, and we make them in every size to suit our inspection port. So just to kind of look through some of the rest of our product range here, which hopefully will be, we'll go into more detail in upcoming webinars. But yeah, so we have our Integrity water indicator, which gives you an early indication of moisture under your insulation. We've got our insulation spacers, and so we've got 2 different ways we do this. We've got like a silicone block and then a polyphenylene sulfate device that just stabs into the insulation. Our Integrity termination gaskets, which form a watertight seal for any termination point in your insulation system. So traditionally where you would have end caps or bevels, they can also be used along the insulation system to compartmentalize the insulation system. So if you do get a break in your jacketing or some jacketing has been removed for maintenance work or something like this, that you're compartmentalizing the problem to a certain area. So they're fantastic. Our Integrity drain plugs, which again are kind of installed through the metal cladding and through the insulation at low points in the system, just to allow any moisture buildup, a path to escape the system. Our Integrity clamp covers make it quick and easy to seal around protrusions such as Grinnell clamps that come through the insulation and the metal cladding. Again, traditionally it's kind of it's been a fabricated piece that would happen on site. You'd build a metal box or around a Grinnell clamp. So our Integrity clamp covers are a fantastic alternative, quick and easy to use on site. We also have our Integrity fire plugs, which are made from a stainless steel port itself, and they have then a fire resistant pillow on the inside. Some of our latest products are our PTFE spacer wrap. So you'll see it here, it's the white dimple material that is in direct contact with the pipe underneath the insulation. And this forms a non-contact or contact-free insulation system. So it's installed on a pipe prior to insulation being installed. Again, this is a relatively new product for us as well, but it's our insulation ventilation system. So it's made up of a perforated dimple wrap, which sits on the outside of the insulation, forming an air gap between the insulation and the cladding itself. So what this is doing is allowing moisture that has built up in the insulation or condensation from inside, it's allowing it to actually leave the insulation system, flow to the 6 o'clock position on the pipe, and then drain out of the system. So that's our perforated dimple wrap used in conjunction with our vents and drains. So just a quick summary. Ahmad, stop me if you think we've missed anything. But yeah, so we've discussed CUI and some of the related degradations. We took a close look at inspection ports and the CML criteria. Went into depth with our Integrity Plugz and our Integrity Pillows range, and we had a quick look through the rest of our product range. So I think we've received a few questions in, Ahmad. So maybe we'll push on to some of our questions and see if there's any interesting questions that we want to discuss.
Sure.
So I see one of our first questions here, Matt, is again just asking what are the temperature ranges of the silicone and EPDM inspection ports again. So Our silicone inspection ports work from -150 to +450 Fahrenheit. And that 450 Fahrenheit is a constant contact temperature. It's about 232 degrees Celsius, I think it is. And then our EPDM variant is -58 Fahrenheit to +300 Fahrenheit, so 150 degrees Celsius.
Okay, so here is a question, like I would say it's a sharing of thoughts.
Okay.
One issue we observed in our plants is due to the soft rubber, if the hole is not cut out correctly, the opening can be manipulated with the screws, causing the plug cap to not sit correctly and fall open.
Okay. Yeah, I think I can answer that because we've seen that. We've seen that before. Our edge trim where the screw penetrates is
we can show that.
Like 1 inch. Yeah, we might be able to kind of see that. Back up again. Yeah, so you can see here that we've got that large edge trim, and because we supply the template as well, you can cut that hole quite accurately. Even if you're installing it on a tight elbow, you just bend the template itself over where you want to mark it. So that seems to be something that works quite well. It's certainly a huge advantage having the template in every packet, so you can go and cut that hole accurately. But you don't need to be super accurate with it either, because our edge trim is quite thick and allows you to form that seal, even if it's not exactly cut as required.
Oh. Okay, so the next question.
Sorry, I've got the next one here. So someone here just asking, like, are Integrity Plugz specified with any acid owners? But yeah, I think so. Usually specifications are kept in-house. It's not something that acid owners kind of want to share too much, but we are, I know for a fact that we're specified with the likes of Dow Chemical, Suncor, Shell, Devon. We're approved for use with a large number of acid owners. I think every major acid owner at this point, if we're not hard specified, we're certainly approved for use. And even as far as things like we're on the CUI standards, which is kind of the European standards. And yeah, if you need any more information around that, we can certainly help share it. We also, from all these specifications that we've been successful getting on, we've created like a general specification document. So it's to make it quick and easy for specifiers to be able to kind of pull the information that they want and help them build their specification. We've also worked directly in hand with some acid owners to help them write the specification to the detail that they need. So just one other question we have here is, do you have a high temp insulation pad that is resistant to hot oils?
To avoid auto ignition.
To avoid auto ignition. So I know that with our Integrity Fire Plug, we use in the pillow that we have there's a pit jar in there, and I don't have details of it here right with me, but we can certainly forward you a full data sheet on this product. But yeah, this is designed as a fire plug, so it will seal the port opening as required if you're in a fire or very hot conditions.
Yeah, and also it's tested as per like various ULC standards and NFPA standards. That is for National Fire Protection Agency. So yeah, under different conditions. Definitely we can get more details and we can send.
Yeah, I think so. We don't have to in front of us here.
Yeah.
One other question I see here is, do we have distribution in the US? So yes, we do. We've got many partners in there, and we deal with Distribution International, who have branches across the states. Also SBI, and they've got again branches across the states. I think almost several in each state. And NDTsupply.com are a full e-commerce site which sell all things NDT, and they're also one of our representatives in the States. Any other questions there, Ahmad?
Still waiting.
So we answered this one. Perfect. I think there's a few people here who are asking if we can talk in a little bit more detail on some of the other products, which we quickly ran through. But again, I think that they're going to be the subject of upcoming webinars. And again, if you wish to contact us directly, we can speak to you directly on these products or forward you additional information. Okay, so I think that's all the questions that we have for today. So one other little bit of housekeeping, we do have a $100 gift card, which we've done a draw just as we were starting our webinar here today. So I'm just being handed the note here, Andres Sotanawan. So congratulations, you've won our $100 gift card. So we'll contact you here right after our webinar and touch base with you and make sure we get that to you. So again, it's just a little thank you for everyone for joining us here today. So again, I just kind of like to point out that we're quite active on our social media, especially LinkedIn. So please feel free to follow us there. That's kind of where we bring our latest product information, field shots, any learnings that we've had. So it's always great to get on our LinkedIn and see those updates. Also, please feel free to reach out to us directly anytime if you have any additional questions after today's webinar. So again, my name is Karl Metcalf, and my email address is there, karl@integrityproducts.com, and my direct cell number if you wish to reach out to me. We've got Ahmad there as well for any technical questions. The more technical, the better. The tougher, the better. And of course, you can reach us through our info email, which is info@integrityproducts.com. And please feel free again to check out our website, and lots of additional information there. We've got lots of product photos, field shots, videos, and we also have a YouTube channel, which we've got, again, lots of videos. We are very lucky that from a lot of the contractors in the field, we get certainly weekly photos coming from them or install videos and stuff like that. So where appropriate, we try and share them as best we can. But yeah, so again, thank you everyone for joining us today. I hope the presentation was informative and of value to you, and hope to see you on our next webinar. Thank you.
Thank you.